Hi, in this lesson I'm going to show you how to add and subtract fractions. Now, not just fractions with numbers in them, but also fractions with variables in them. Therefore, we are going to be working with rational expressions, and many of them, or all of the examples I have in this one, will have unlike denominators. My first example here, I have my two fractions that I'm going to add together, and I notice that I need to get a common denominator, because to add or subtract fractions, we have to have a common denominator. So to do that, I look at the 5n denominator and realize that the factors of 5m are 5 and m. I then look at the factors of m, which are just m. Oops, let's keep that red. And then to find my common denominator, what I like to do is I like to look at this one and ask myself, what is the 5m missing that the m has? The answer is nothing. Therefore, I don't have to do anything to the first fraction. But then I come to the second one and I go, well, what is the m missing that the 5m has? The answer is it's missing the 5. So I have to multiply my denominator by 5. But then since we're working with a fraction, that means I'm going to have to multiply my numerator by 5 as well to keep that fraction equal. Now, once I do that, we said that first fraction, that's not going to change, because the denominator did not change. So I still have m plus 2 over 5m. And then we're going to add. Now the second fraction is going to change the way it looks, not the value. So now I have to multiply my numerator by 5, which is going to put me now at 5m minus 30 over 5m. Now, since I have a common denominator, I can add my numerators together. And to add my numerators together, I look for like terms. So I see m and 5m here. If I add those two together, I end up with 6m. And then I go to the 2 and the negative 30. If I add those together, 2 plus negative 30 is going to put me at negative 28. So instead of adding a negative 28, I'm just going to subtract 28. And that's still all over 5m. So I look at this and go, that's my answer. Now, sometimes you want to look and see if you can simplify. To do that, we'd want to factor the numerator. And when I look at that, I see that 2 is a common factor to both, so I could factor the 2 out, and then I'd be left with 3m minus 14. That's still over 5m. And notice there's no common factors that are going to divide out. So I could leave my answer as this in factored form or this where it's multiplied. My next example, I'm subtracting fractions. So again, I have to find that common denominator. And I'm going to start with the first one, u squared minus 9. Factors of u squared minus 9 are u minus 3 and u plus 3. Factors there. And then I'm going to look at this part. Factors of 4u plus 12. Well, 4 is common to both of them. And then the other factor would be 4 plus 3. Now to find that common denominator, again, I'm going to ask myself, what is the u squared minus 9 essentially missing that the 4u plus 12 has? Well, I look at it and I notice it's missing just the 4. So I'm going to have to multiply the denominator of that one by 4. Now what I'm going to do is I'm just going to slide all of this over a little bit to give myself some space. So I have to multiply this denominator by 4, which means I have to multiply this denominator, or that numerator, by 4. Now, this is missing the u minus 3. Therefore, I'm going to have to multiply this denominator by u minus 3, and then this numerator by u minus 3. So when I do that, my new fraction is now going to be, so I'm looking at 4 times the u plus 1, so I'll end up with 4u plus 4, and that's over, and then I'm going to write it in factored form, so it's 4, that's from the blue 4, but then the u squared minus 9, remember u squared minus 9 is u minus 3 and u plus 3, and then we're going to subtract. Now I have to FOIL this together, the 2u plus 3 and the u minus 3. So if I multiply here, I get 2u squared. I multiply here, I'm going to have minus 6u I multiply my insides, I get plus 3u, and I multiply my lasts, I get minus 9. And that's all over, I'm going to put it in factored form again. So it's 4, and then u plus 3, that's the 4u plus 12, and then we had the u minus 3. So our denominators are common. I put them in different order. That doesn't matter. Now we can work on the subtraction. And it might be helpful to first, before we actually subtract, I think we should simplify this part right here first. So I'm going to write that, let's just rewrite the whole problem. So I still have the 4u plus 4 over, and then it's 4u minus 3, u plus 3, minus. Now here's where I'm going to put that, or simplify this part. So I end up with 2u squared, and then it'll be minus 3u, and then minus 9, and that's still all over the, and I'll put it in the same order this time so they look identical, and then u plus 3, because the order when we multiply doesn't matter. Now I can work on the subtraction. So find my common, or my like terms. I'm going to put this in descending order, so I see that I have the 2u squared here, but remember we're subtracting, so in my answer I'm going to have a minus 2u squared. And then I'm going to go to my u terms, which I see here and here. 4u minus negative 3u is going to be a plus 7u. And then I look at my constants. I have a 4, I have a negative 9. 4 minus negative 9 is going to be plus 13. And then that's all going to be over 4 u minus 3, u plus 3. Now we'd look to try to simplify this, but that numerator, or the whole numerator here, is not factorable. Therefore, this is our final answer. Because we can't factor the numerator, therefore there are no factors in the numerator and denominator that will divide out. And there is our final answer to that original subtraction problem. And then I have one more here where I'm going to subtract again. So again, we have to find a common denominator. To do that, we have to factor. So I'm going to factor my first denominator. And the factors of that will be c minus 3 and c plus 1. And then this one just is the c plus 1. So to find my common denominator, I notice that this is missing the c minus 3. So I'm going to have to multiply this denominator by c minus 3, and I'm going to have to multiply the numerator by c minus 3. Then I'm going to go down to my next line. So I have c squared plus 4c minus 5 over c squared minus 2c minus 3, because that's our common denominator. Oops, you know what, I'm not going to write, I want to write it in factored form. So I'm going to leave it as the c minus 3 and c plus 1. And then we have to subtract. Now we have to multiply here. So we're going to end up with 2c minus 6 over, and then we have to FOIL that denominator. Well, I'm not going to FOIL it because that would be multiplying it back together, and I'm just going to leave it in factored form. So we're still with the c minus 3 and c plus 1. I just switched the order there so that it would look identical to my first fraction. And now, since our denominators are the same, we can subtract. So I go through and I look for like terms. C squared, no other like terms like that, so I know my answer is going to have a c squared in it. And then we'll go to the constants. So I have the 4c and the 2c. 4c minus 2c is a positive 2c. And then my constants, I have negative 5 and a negative 6. So negative 5 minus negative 6 is a plus 1. And that's, oops, still all over my common denominator of c minus 3, c plus 1. Some would look at that and go, I'm done. But remember, we always should look to see if we can factor. And if I look at this numerator, I see that I can factor the numerator at c plus 1 times c plus 1. That's still all over c minus 3, c plus 1. And the reason that we want to do that is because now we see that our c plus 1s will divide out. And all we're left with is c plus 1 in our numerator and c minus 3 in our denominator when we subtract those two original fractions. And that's going to conclude my lesson on adding and subtracting rational expressions.